Hey, this is AOC2022, and today I'm looking at Advent of Code 2022, Day 22 Monkey Map. And this is a video, I saw this back on the day, it was out, but I was traveling, and I just thought this is too complicated. I wanted to try to make a video out of while traveling, so I'm going to go over my code today. Let's first start with the challenge. So basically, we're walking through the jungle, and the monkeys are going to give me a surface that's going to look something like this. And then at the bottom, so there's going to be spaces, which are empty spaces, pound signs are walls, and then blanks are not on the map. And then at the bottom, I'll have this set of instructions. So the way the map works is, well, so first I'll have these instructions. So a number means to move forward that many spaces. So move forward 10 spaces, for example. You start, let's see, you start in the, I'll come back. Left or right, RO, means you turn left or right, 90 degrees, and then you move, turn, move, etc. So, for example, 10 R5 means forward 10, clockwise 90 degrees, then forward 5. You begin in the leftmost open tile on the top row, and you're facing right. If an instruction would take you off the map, you wrap around to the other side of the board. So, if I start here, top row, leftmost, facing right, if I move 10, I'm going to get to here and I'm going to stop because I hit a wall. So I'll just stay here and finish out the 10. Then I'm going to turn right, so now I'll be facing down. And then I think I moved 5. 1, 2, 3, 4, 5. So put me here, etc. If I were to walk off the board, let's say I walk off the board going to the right here this way, I would just show up over here. If I tried to go off the board to the left this way, I would actually just stop in this last tile because I can't continue because it's a wall. If I go off the bottom, I come back on the top. If I go off the bottom down here, I come off this top right here. And that is basically it. So here's an example of a course they take where they go this way, down, across, down, over, then down, which takes them up, that wraps around to here, and then they run into a wall, and that's the end. So from there, I calculate a password, which is the row number 1,000 times the row number I'm in, 4 times the column, and then the facing, where the facing is 0 for right, 1 for down, 2 for left, 3 for up. And I'll say, what's the password? So let's jump over here and take a look at this code I wrote. So I had created some constants here just to help me think about the world. So for example, stepping a coordinate, if they want me to turn to the, if I'm facing right, so this is basically say, take my current facing and tell me what the change, what one step's going to do to me. So if I'm facing right, I'm going to change 0 in the rows, and I'm going to go +1 in the columns. If I'm facing left, I'll be -1 in the columns. If I'm facing up, I'll be -1 in the rows, and etc. Left turn and right turn say, given my current facing, what would my new facing for a left and a right turn? And then face score is how do I convert the score. Next, I created a world class. And so basically what this is going to do is I'm going to start my dictionary, my grid, which is going to be a default dict, where the default is it's a space. And so basically that means by default, every space is not on the board. Because I need to track 3 different things. If I can only have to track 2 things, like wall and not wall, then I could just use a set and store points. But because I really need to track wall, and not part of the map, like wrap around if you hit here, I really need to have, I'm going to use a default dict. Also have my self.position and my self.dir. I'm going to start self.position at none because when I parse the grid, I will set it there. My self.dir, I know I start facing right, so I'll start that way. And then I'll call 2 functions, parse grid and parse instructions, just to sort of, again, get all the data in. Parse grid will start, I'm going to track the maximum column and the maximum row in my grid, and I'm going to store those things as well. And so I'll start them both as zeros, or at least I'll start maximum column as 0, and then I'll get my maximum row as I go. And that's just because I can enumerate. I'm going to get that over enumerating here. I guess I would also get my max column. No, I can't be guaranteed that I don't know which row the max column will be in. I know the max row will be the last row I get to, so that's why I don't have to worry about presetting this. But instead, for max column, I'll start at 0, and then each time just set it equal to the max of the current max column. And after each row, I'll get the, how far did that C go, and see if it's the biggest. I'll basically loop over each space in the each row, and I will set the self.grid of RC to the character it is. And if I haven't set the self.position yet, which means I'm in the first row, first legit, first non-space character, I will set my self.position there. Now I got to parse my instructions, and this is simply going to take that string of numbers and R's and L's and convert it to a list of that I can walk over more easily. And so basically what I'm going to do is I'm going to have this temp variable, and so for each character in the instructions, if it's R or L, then I'm going to say if there's a temp, if there's something in temp, which would be like a number I've been tracking. Well, I'll come back to this actually. If it's not R and L, so assuming it's in this, I'm going to add the digit to my C string. So, at the beginning we saw 1, 0, R. So temp will start here. I'll get to 1. It'll append the 1 to temp, loop around. It'll then get the 0. It'll append the 0 to temp, loop around. Now it gets to R. So if there's a temp, there is, it's going to append the int of temp to my result. And then it's going to reset temp. And then it's going to also append that turn character. So I'll actually add 2 things. There's a chance the end is a number, and if it is, then I will miss this chance to append it. So I will, once this loop is done, also append it there. And then I'll set self.instructions to this result array. So now instead of having a string, I basically have just parsed that into a series of instructions, movements, and turns. Now I'm going to create a step function, and this will just basically be, what do I do? How do I process an instruction? And so this basically assumes, this is not how I process instructions, how do I process a move instruction? So I'll pass in a number. So say I pass in 10, I'll do loop of 10. I will get the current position. I'll get the change in position for my step based on my current direction. I will, if the next step is a dot, I will update my position, and I'm basically done. If the next step is a wall, I just return. I'm done. I don't move, nothing changes. If the next step is off the map, then I have to sort of figure out how I looped. And so if I'm going to the right, then I'm going to go to column, I'm going to move myself way too far. So I know I can't be, column 0 is going to be the minimum, so I'll go to 0. If I'm going to the left, I'll loop to the maximum row, or maximum column, sorry. If I'm going up, I'll go to the maximum row. If I'm going down, I'll go to the row equals 0. Presumably my directions will be one of those 4 things. And then I'm going to just basically say, while R and C are blank, step. So just basically walk till I find the place I wrapped. And so once I've reached something that's not a wrap, if the first thing I reach is a space, then now I know I can update my position to that thing, and now I've taken my step. If the first thing I reach is a wall, I just return, because I'm actually not going to take this step. I've kind of figured out where the next step is. It's a wall, so I just stay where I am. And I've got, again, some assert falses in here just to make sure I don't hit something I'm not expecting. I have the turn instruction, so if it's R, set myself basically do right turn of my current spot into my new spot, my new facing, and same thing. And now I've got this run function, and run is going to loop over the instructions, which I already initiated. If it's an R and L, I'm going to turn, else I'm going to step. And then at the end, I'll get my position, and I will use that to calculate the score and return it. So with this whole world defined, what I really need to do is create the world object, passing it the map string and the instruction string. And then I just need to call run, and it will return the score for me. So that's exactly what I do down here. With open, read the thing in, I will split on double new line, stripping off the trailing new line, and get map and instructions. I will pass that into here, and I will run it and get part 1. And so this is all pretty simple, actually. Let's see, we can go into day 22. You can Python day22.py. What's day 22? Part 1.py on input. We get 117,054. We come back here and check this out. That's the correct answer. We could also do this on the puzzle input, 6,032. So that works great. So this challenge, it was a bit of like building up the code, but it was not too hard. And this part didn't really give me much trouble. So let's go ahead and check out part 2, because part 2 is where it gets kind of crazy. So in part 2, we realize basically that we're not walking around this weird map with blank spaces, is that we're actually walking around a cube. And that if you look at this, it's the map, the input is broken into 6 faces. And they've labeled 1, 2, 3, 4, 5, and 6. And if we fold this around, so like 4 is on the top, 2 is on the bottom, 3 is on the left. This would be on the kind of top side. 6 would be on the side, 5 would be on the side, etc. And this is where it gets really challenging because now what happens when I walk off an edge, if I walk off, let's see if I can picture this one right here. If I walk off this one going left, where I actually end up is on 3, on this 3, going down. And wrapping your head around this in 3D is incredibly challenging. And so they show some examples of this. Yeah, so if you walk off, let's see. So they show some examples of here where they walk around. In this case, when they go off here, they're actually that comes right here. So this is what they come off here, come down here. This comes actually onto this right here. And so because we're in 3D space, it's weirder. But and then the rest of it's still the same. So all the only thing I have to really change is how I wrap on these corners. But that's incredibly difficult. So let's take a look. I should have said this in the intro. I did kind of a cheating way of doing this because I think it's possible to write this in such a way that you handle any input. But we can look, for example, my example.txt has 1, 2, 3, 4, 5, 6. My input.txt, if we look up here, it goes 1, 2, 3, 4, 5, and then 6 is over here off the screen. And so figuring out how to just fold a generic one programmatically is really challenging. And so I didn't do that. I got frustrated and just gave up with that. So looking at our part 2, the only thing that needs to really change is I added this parse edges function. And what this is going to do is it's going to prep all the things I need to know about rolling off the edges. And we'll go over that. And then we'll first come down here and in step, if we have self.part2 and we find ourselves in one of these self.edges points, right? So we're going to store an R, a C, and a direction on self.edges. And if we find ourselves in one of those points, we're just going to update ourselves to, we're going to say NC, basically up here at the front, we get what the next row and coordinate is going to be and the next direction is going to be. And if our current spot's in one of these things, we're just going to overwrite that and be something different. And then we just do the rest of our checks just like normal, right? Except for we should never get to this, we assert not part 2 because we're handling all that up here. And so then we are always going to land either on a dot or on a wall. So all the rest of the stuff is irrelevant for part 2. And that's basically it. So I'll show you what I did. And again, this is really inelegant. I don't recommend this. There's probably a lot of better solutions out there. So if we're dealing with the example.txt, basically what we're going to do is we're going to just figure out for each edge, what does it look like to walk off? And so again, I'll pop up on the screen kind of my quick picture here of what this looks like. But if I walk off edge 1 here, or the edge I've labeled 1, I'm going to end up, and that is going to be on the row 0, the columns being 8. So in this case, scale is 4. So 8, 9, 10, and 11. And I'm facing up. If I'm in row 0 and 8, 9, 10, or 11 facing up, and I step, where I'm going to show up is on row 4 in 3, 2, 1, and 0 facing down. And the counterpoint is also true. So if I say in row 4 in 3, 2, 1, or 0 facing up, I'm going to end up in row 0 of 8, 9, 10, and 11 facing down. And so I went through and just hard-coded for each of the example ones, these right here. And then for each of the my puzzle input, I did a different one. So basically, again, here's the 7 pairs of edges. There's always going to be 14 pairs of overlaps. That's what we're going to have to deal with. So, and once I've pre-computed that, I just sort of know that if I'm in this spot facing this, in one of these positions facing this, that my next thing is really going to be this. And I've got all those hard-coded in as pairs. And so I can check the key here and then get the next step here. Again, this is not elegant, but it works. And so we can run this. A22 input, oops, not O, input text. And it runs very quickly. I get 162,096, and there's the puzzle, there's the result. So it does work. I made some, again, I spent a lot of time with paper and pencil, like sort of mapping out these mappings, and some mistakes, and I would get the wrong error, and I have to like really step and go through and troubleshoot. You might have seen, I thought I had a print statement in here somewhere where I commented it out. So there's some print stubs in here I've done to try to figure out what was going wrong, where I made a mistake. This one as well. And it's just kind of a pain in the butt. And honestly, it's an inelegant solution. There's got to be a better one, but I didn't get to it. So I'm going to go ahead and call this video here. Hopefully this was useful to you, and I appreciate you sticking around till the end. I'll talk to you next time. Bye.